The objective of this lesson is to identify when two expressions are equivalent. In previous lessons, students have learned how to write an algebraic expression to represent a problem. They have also learned the different parts to an algebraic expression. The emphasis of today's task is to discover that just as whole numbers can be decomposed into various ways, so can algebraic expressions. This task will help students write an expression to calculate the amount of fencing needed to enclose a rectangular garden. The fence material is available in 3 sizes. The length of the smallest piece is unknown, and the other 2 pieces are 2 times and 3 times as long as the smallest piece. There are multiple parts to this task. Let's look at part 1. Use an algebraic notation to represent the length of each of the 3 pieces. Use centimeter cubes to represent the 3 pieces. Then draw a representation of each piece and label the lengths. The problem states that the smallest piece is unknown. Let's label this X. The other pieces are 2 times and 3 times as long as the smallest piece. This will be represented by 2 times X and 3 times X. Using centimeter cubes, the X will be represented by 1 cube. The 2X is represented by 2 cubes, and the 3X is represented by 3 cubes. To draw this, start with one small line and write X below it. Then draw another line that is equal to the 2 of the small lines and label it 2X. Finally, draw a third line that is 3 times the size of the small line and label it 3X. Part 2 states, if the length of the garden is 8 times as long as the smallest piece of fencing, how can the length be represented? Draw a representation of the length. Our smallest piece is represented by X, and this part asks for 8 times X. This would be written as 8 times X and can be drawn by taking 8 of the X lines. Part 3 states, create the length of a garden using more than one size of available fencing. Use algebraic notation to represent the length of the garden using the fencing pieces. One way to do this would be to have 2 of the 3X size pieces for 6X, plus 1 of the 2X size pieces for 2X, for a total of 8X. This would be written as 2 times 3X plus 2X equals 8X. Part 4 asks, is there a different way to create the length of the garden using more than one size of fencing? Use algebraic notation to represent the length of the garden. Another way would be to have 2 of the 2X size pieces plus 1 of the 3X size pieces plus 1 of the X size pieces for a total of 8X. There are many ways to arrange these pieces to equal 8X. The expressions look different but are all equivalent. They still equal 8X. Part 5 asks, if the width of the garden is 4 times as long as the smallest piece, represent the width using algebraic notation. X is the smallest piece of fencing. Therefore, if the width of the garden is 4 times the smallest piece, the width would be 4 times X. Part 6 states to think of 2 additional ways to show the width and use algebraic notation. One way to make 4X would be a 3X size piece plus 1X. Another way would be a 2X size piece plus another 2X sized piece. Again, there are other ways to create 4X. Part 7 asks to calculate the total amount of fencing. Write the expression using algebraic notation. To find the perimeter of a rectangle takes 2 times the length plus 2 times the width. If the length is 8X and the width is 4X, the algebraic expression will be 2 times 8X plus 2 times 4X for a total of 24X. Another way to calculate the perimeter would be to add up all of the sides. 8X plus 8X plus 4X plus 4X equals 24X. As in the other expressions, there are a variety of equivalent expressions to find the perimeter. The last part of the task is to draw the rectangular garden. Label the length and width. Explain how many pieces of each size you will purchase. Write an expression for the area inside the fence. Start by drawing a long rectangle. Label the length 8x, and the width, 4x. Previously, we examined different ways to make the length of 8x and the width of 4x using our fence pieces. Let's pick one way for each and calculate. For 8x, let's use two 3x size pieces plus one 2x size piece. For the width 4x, let's use two 2x size pieces. There are two sides that are 8x, which means we will need to multiply the 2 times 3x plus 2x by 2. This means that we will need 4 of the 3x size pieces and 2 of the 2x size pieces. There are two sides that are 4x, which means we will need to multiply the 2 times 2x by 2. This means that we will need 4 of the 2x size pieces. The total amount we need to order will be 4 3x size pieces plus 6 of the 2x size pieces. The area of the rectangle is found by multiplying the length by the width. We know the length is 8x and the width is 4x. Therefore, the algebraic expression for the area would be 8x times 4x. The objective for this lesson was to identify when two expressions are equivalent. We met this objective by creating multiple equivalent algebraic expressions to represent the perimeter of a given length and width of a rectangle.